I've been researching wine and climate since 2003 when I started my PhD at Stanford. And so I've given talks on this topic many times, but this was a hard one to write because things are so bad right now in my hometown of California, and they look a lot like this or even more scary than this. This is the 5th year in a row of catastrophic wildfires in California. And so which we know are being made more devastating and more likely and more frequent by human-caused climate change. So we're really at a critical moment for life on Earth, and that's kind of the takeaway. I won't bury the lead too much. This is where I grew up. This is the vineyard just up the hill from my parents' house in the town of Sonoma. It's a Cabernet Sauvignon and Cabernet Franc vineyard that was planted just after I was born. And it's an incredibly beautiful place that I have a strong attachment to, and it's becoming unrecognizable to me because of the changes that people are making to the climate and to nature. So the takeaway, to answer up front the question in my talk title, what can wine tell us? Wine is telling a similar story to the rest of life on Earth as we study it across ecosystems, across countries, across contexts. Life on Earth is really in big trouble. And we're at a critical point, and it's up to us to make it better. We have a very limited time left to stabilize the climate in tolerable limits and to prevent further catastrophic biodiversity loss. So that's really what my talk is about. The first half, I'll be showing some details drawn from my own work, among others, on what we know about wine and how it's related to climate and what that tells us more broadly about agricultural systems and human systems and natural systems under climate change and biodiversity loss. And in the second half, I'll be talking about what we can do about it. So from synthesis science, which is thousands of colleagues over many, many years pulling together painstakingly the state of the art, we know that nature and ecosystems are deteriorating worldwide. This was a really tough report to read, and there have been several even more devastating reports out since, this one last year from IPBES. But the global assessment basically said about half of ecosystems have declined, or been disrupted or disturbed or destroyed by humans since monitoring began. And about a quarter of species, the life that we share the planet with, is at risk of extinction. We know from work by Soren Fauby and colleagues that it will take millions of years for evolution to replace the mammal biodiversity that's already been lost. So we're already in a really dangerous decline of the web of life on Earth. And that matters because species are cool and beautiful and give us lots of pleasure and joy, hopefully, including wine, but also because we need life on Earth in order to live and to thrive. Nature is the source of sustenance for human beings and for all other life. It's clean water and clean air. It's healthy ecosystems that can take up and recycle wastes that we produce. And we're really undermining the planet's ability to cope with and sustain life. And that is a big problem. Similarly, on the climate side, if I summarize, I have on the shelf here behind me the books from the IPCC. You can see they're about this thick, but if I shrink it down to just a few words, what all that hard work over many decades tells us, and even centuries now of climate science, is it's warming, it's us, we're sure, it's bad, and we can fix it. So there's really overwhelming universal scientific consensus now on these first 4 points, and the focus really must be on the urgency and the need to fix it. We've missed so many opportunities until now, and we just can't afford to do that any longer. Let me take you through some of my research and extrapolate or draw out from there what some of the lessons are for the rest of life on Earth. This is from work looking at Pinot Noir, my favorite wine grape, in California. And what it shows is that there's an optimal temperature for producing high-quality Pinot Noir. And when the temperature gets too hot, the quality and therefore the price decline dramatically. So this is illustrating a difference that might not sound like a big deal of just a degree or two, can make a really big difference for life. And that's because systems have evolved over a long time to live where they do and to make a living where and how they do. Temperature and climate is basically determining who can live where and how they can make a living. And that's true both for humans and for natural ecosystems. So by changing the climate, we're really changing the possibilities for civilization and for nature around the world. Let me show you an example of what this looks like for grapes. This is an illustration of what the process of ripening looks like in a grape. So over a couple of months during the growing season, a grape goes from this small, hard, round, green ball, which is high in acid, and over time it's losing that acid and respiring it or transforming it into sugars. That's the process of ripening. The goal is for wine growers to take care of the grapevine in a way that balances the ratio of sugars and acid. So sugar is going to ferment into alcohol, which is a part of wine, but you don't want it to be too high to overpower the flavor and experience of wine drinking. You want to still retain some of that acid so it has a crispness and freshness. And what's really important and what really distinguishes the most valuable and delicious and precious wines is this kind of mythical and exciting part about flavor and aroma compounds. And those come from the grapes. They can't be synthesized, they can't be added afterward. There are some parts of winemaking that play a really important role. But basically, nature is in charge here. I've had winemakers from some of the best wineries in Napa and Sonoma tell me, my job is just not to screw it up. Great wine really grows itself almost under the care of skilled viticulturists, but you can't make a silk purse out of a sow's ear. You're really dependent as a winemaker on what happens in the vineyard in order to make great wine. And what's happening with climate change is this sort of biological ballet that has evolved over a very, very long time span now very quickly is becoming dysregulated. The systems are getting out of whack. And that's because ripening is happening faster. You have an earlier start to the growing season and more accumulation of growing degree days or temperature during the growing season. So the grapes are ripening faster, and you see that acid to sugar ratio has shifted back in time. But now that kind of sugar ripeness is happening at a point where flavor has barely started to accumulate. And the peak of flavor may be lower as well. So it's not possible to grow as good grapes. You also have a problem with color accumulation, and you may not get full color accumulation under hot growing conditions. So you can see there's similar studies looking at, for example, the interaction between pollinators and their target flowering species or predators and prey. Nature is part of a system, and the web of life is really interconnected. And when we start unraveling it and changing the system, it can have really worrisome consequences. This is showing how grapevines have changed over time. So these are harvest records taken over many years, shared with me by a colleague, Leon Webb from Australia. So this was a grower who'd been growing Chardonnay in place for many years. And what happened as the growing season is getting pushed back, so they've been recording on the x-axis across the bottom is harvest or date where they're tracking the ripening of sugar. On the y-axis is the sugar level, so that ripening curve that we saw in the previous graph. So each line is a year, and they're showing how that ripening happens over time. And in recent years, they've had to actually add a staple and push it back a new piece of paper so that they can start tracking ripening because it's happening so much earlier. So that was at one vineyard over time. When we zoom out a bit and look at whole regions or continents, we see a similar story. This is some data from France that colleagues and I have used to show that harvest dates have been substantially declining, especially in the last couple decades. That downward line is very striking across the three regions in France that we studied here. Going back much further than that, some scientists about 15 years ago in a Nature paper looked at Burgundy harvest dates. So monks have been growing grapes in the Burgundy region of France for many centuries and recording those harvest dates. And because grapes are so closely linked to climate, like other forms of life, they can be used as a proxy or an indicator to show what the climate was doing. Something like tree rings or corals also record temperatures in the way that they grow. So we can look at these harvest dates as a way to understand what past climates were like, and what you see is certainly a lot of variability, but overall a relatively stable harvest date and therefore a relatively stable climate. And when we zoom out much further back over many millions of years, what we see here is how unprecedented the changes that humans are making to the climate right now are in a human context. The Earth has been through many changes in climate before. Of course, before there were humans, it used to be very much warmer indeed. So natural climate variability is obviously an ongoing phenomenon. But what's really striking about this graph to me is the time scale of how long it usually takes to make these kind of big changes. And especially if you look at the last 10,000 years, this yellow line that's drawn in the middle horizontally, you see how relatively stable the climate has been. And that is the time period that humans have basically developed civilization, agriculture, and life as we know it. And that's not a coincidence. We've built our cities and our farms and basically planned our lives around the climate of the last 10,000 years. And we're rapidly leaving that climate behind because we've already warmed about 1 degree Celsius from human-caused climate warming. So you may know that from the Paris Agreement, this international climate agreement that all countries of the world are a part of, even though the biggest historical emitter, at least at the moment, the leader has indicated wants to leave that agreement, but the US is still part of the Paris Agreement for now. All countries have agreed to this to limit global warming well below 2 degrees Celsius and pursue efforts for 1.5. We know from a recent IPCC report in 2018 what a huge difference for life on Earth, both people and nature, it makes to limit warming to 1.5. It's 2 to 3 times more habitat for species, for example. It's really, really substantial in terms of the essence of life, basically. And this graph here from some work with colleagues out earlier this year shows even 2 degrees of warming is really a very different world than the one that I grew up on and the one that we're used to. The purple regions are at the bottom, in the bottom left corner here, you see current wine growing regions today. And then the big map shows the purple regions are areas that were shown to be suitable for wine growing by our model that would no longer be suitable, or at least the varieties that would be suitable now would not be suitable in the future under even 2 degrees of warming. The green areas are where there would be potential for expansion of wine industry, but we'll talk more about that in a moment because, of course, it's not the case that there are vast empty continents waiting to become wine regions. We know that we need to protect land for nature as well. We're headed for something like 3.5 degrees of warming at the moment, which is really bad news because we're not at all on track. The governments of the world have so far woefully failed to reduce emissions at the scale and the pace that's needed. And 3.5 degrees of warming, or close to 4 here, would really be a world that I think we would not recognize as our home planet. Looking at the kinds of changes that would be in store here for wine is very striking, but I have to say I have heard that it's possible to live without wine. I haven't tried it myself, but apparently it does work. But it's incredibly disruptive and dangerous for systems that it's not possible to live without. Food production, water delivery, really, really fundamental human needs are really reliant on a stable climate. So when we talk about climate, we basically have 3 choices of how to react to climate change: mitigation, adaptation, and suffering. Mitigation is addressing the root cause of climate change, which is preventing greenhouse gas emissions from accumulating in the atmosphere and driving climate warming. Adaptation is dealing with the impacts of climate change, so making adjustments to a new climate. And suffering is what's left. It's what can't be avoided and can't be adapted to. It would have been much better to pursue this path, basically to aggressively mitigate in line with the science which has been in place for a very long time of the risks of climate change, and make the transition from dirty to clean energy and sustainable or unsustainable to sustainable agriculture that we know are necessary. Some adaptation, if we had started this earlier, might still have been necessary, but I think we could have really avoided or minimized suffering. That's not the path we're on right now, and this really keeps me awake at night because we, so far, are really failing at both mitigating and adapting, and instead ending up with a lot of suffering. So we know now, unfortunately, that some suffering is inevitable. There are, from the warming that we've already caused, the 1 degree of warming we already live with, and makes this world, essentially, we live in a world of dangerous climate change already. What we're trying to do now is avoid intolerable climate change and protect what matters most to humanity and to life on Earth, basically. So to do that, we need really aggressive mitigation, reducing emissions, to zero, and also much bigger investment and work in adaptation to deal with the consequences that are already in place and are coming. So I'll talk now a bit about adaptation. There are quite a few options for climate adaptation for wine growers. Work that I did in Napa and Sonoma, interviewing and speaking with growers and making observations there, showed that even 10 to 15 years ago, growers were already aware of climate change, were already making adjustments, and were preparing to make bigger adjustments. What this shows is that basically the closer you get to root causes, the bigger effect you can have. So if you start at the end of the chain with winemaking, it's relatively limited how big of a change you can make with that kind of adaptation or adjustment. There are a number of farming practices that change the light and temperature or microclimate really of the vine and the ripening grapes themselves that can play a role. There are decisions that are made usually on every several decades, things about planting, so what variety you use, the angle that you planted relative to the sun and the wind, and so on. And then the biggest adaptation or the biggest change would be to move site, to establish new sites which have a new soil and climate. And I think that's been a focus in the past, but I think I really want to warn against that as a plan. I mean, humanity has to live on the planet that we have. We know that we've already destroyed about half of natural ecosystems. We can't keep doing this and have a stable and intact web of life to keep us alive. So we really have to stop cropland expansion. That's an urgent priority, both for nature reasons and for the communities and ways of life and livelihood that already exist in places around the planet. So it's not going to be feasible to go flitting around the world planning to just move everything willy-nilly. We really have to focus on adapting as much as we can in place and mitigating aggressively to avoid changes we can't adapt to. One option for adaptation is to harness biodiversity. So a few years ago with some colleagues, we looked at the use of diversity in wine growing now. And what we found is that as in many other systems in agriculture, there's a big trend towards homogenization and globalization. And what that looks like is out of the many, many thousands of varieties of grapes that have been, wine grapes that have been developed over time, only 12 of them constitute about 80% of the global wine market. So that's far less than 1% of the available diversity that's actually being used. These darker red circles on the map show a greater concentration of these 12 varieties, which you see at the bottom here, and I'm sure they're names you recognize from the Systembolaget or the supermarket shelf. So one adaptation is to diversify these areas, which are especially the New World wine growing regions that you see circled here, where there's much greater diversity in Europe and particularly in Italy and other parts of the world. So looking to these areas of where biodiversity in the grapevine has been preserved, these white circles, actually, I see that the red circle here is a little bit in the wrong place, but Italy was one of the most biodiverse places that we found in this study, and there are a number of varieties there that are suited for growing in warmer and hotter climate and drier climates. The reason that can help, that biodiversity is so important, and this underpins why we need to be protecting intact ecosystems and the species and the interactions and functions that live there, is because there's this natural diversity in how species respond to climate and other drivers or stressors. So what this shows is the four developmental stages that are tracked in the grapevine. So starting to grow in the spring, developing flowers, the beginning of ripening, and harvest. And you see in this bell curve shape that there's a range or diversity of response time, and we could be much better harnessing that to choose varieties that are suited to the current climate, not to the old climate. This is just another way of showing that basically these international varieties, those 12 that I listed on the previous slide, have a pretty narrow range of ripening and are shifted to a not very great water use efficiency. If you broaden the scope and include more varieties, here from a study working at UC Davis and drawing from other sources, you see that there's a much greater potential to ripen at different times, potentially during a cooler period where it's easier to retain flavor compounds and ripen more slowly to allow the biological ballet that I showed you earlier to sync up. Yes, so I mentioned here the circle's in the right place. Sorry about that. Looking for diverse areas for possible new varieties. Excuse me. But here's some bad news. It's not possible for humanity to completely adapt to the changes that we've already seen, that we will see at 1.5 degrees of warming, and certainly above that, it just gets worse. So a new study, we showed that two really important trends that I think are widespread and often found across studies. One is that harnessing diversity could be a strong adaptation strategy. As you go here across from 1 to 11 on the x-axis, that's going from just one variety like Cabernet Sauvignon, for example, to a range of varieties. And allowing this kind of turnover within existing growing regions could help preserve those as wine growing regions. The other important trend is that the more warming we have, the more loss and damage and harm we can expect, and the more it's not possible to mitigate or adapt or avoid losses. So you see there's a really big difference in remaining suitable wine growing regions from 4 degrees of warming, where more than 80% of wine regions today would be lost without adaptation, and still over 60% even with adaptation. Those are really bad numbers. So this, unfortunately, is what we're doing right now. We have not done much climate mitigation globally. Emissions have been going up consistently. This year they are down, but for a reason, of course, no one would want because of the global pandemic. We've not been doing nearly enough or sufficient climate adaptation, and as a result, we're already seeing a lot of suffering, and this is going to get worse until we address the root causes and actually stop climate and biological destabilization. So as I said, these ongoing fires in California are affecting my friends and family who can't go outside because the air is unbreathable and hazardous, some of whom are evacuating and worrying about losing their homes. This headline was really tragic from the San Francisco Chronicle newspaper a couple days ago, that some people have lost homes that they just rebuilt from catastrophic fires 2 or 3 years ago and have been struck again. But we have to realize this is not a lack of mercy from God. This is a choice that we are making by destabilizing the climate and failing to take care of and manage ecosystems. And we have to make different choices to avoid this kind of suffering. This is just another graphic to kind of show that there are limits to adaptation, and basically I'm concerned that California and where I come from is reaching those limits, or has already crossed those limits, really. So when we talk about what we can avoid, if it's a low risk and an infrequent risk, we might consider that acceptable, but catastrophic risks and the more frequent that they happen become intolerable. And this map of the fires in California since just 2015, you can see several things. The bright colors are different years and different fires in those recent years. The area is much greater than the gray area, which was historical fires over the last more than century, almost 130 years previously. So there's an enormous increase in wildfires. We know from work from Michael Goss and others that these kind of fires in California are becoming more frequent, lasting longer, fueled by earlier snowmelt, earlier springs, drier summers, and hotter fall days, all of which can be linked to human-caused climate change. So we simply have to fix it, and let's get into now the second half, where I want to talk about what it is we have to do. Basically, it is simple but not easy. We have to stop burning fossil fuels. And right now we're transferring carbon that accumulated over millions of years, 300 to 400 million years ago, as plant life that then through time and pressure became coal, oil, and gas. We're transferring those millions and millions of years of carbon to the atmosphere at this extremely fast rate, and that is what is throwing everything off. And we simply have to stop doing that. We have to shut down fossil fuel energy, like our lives depend on it, because they truly do. And that means along the whole chain of production and consumption. This is a graph that shows the production and processing and sectoral use of fossil fuels, as well as their final end-use consumption. And the important point here is that this whole system has to shift to energy that is not destabilizing the climate. So you may have heard the statistic, 70% or more than 70% of climate damage and disruption is caused by a small number of fossil fuel companies. That's true. But it's also true that about 70% of climate damage is caused by household consumption of things like travel and heating and food, which rely on fossil fuels and emit greenhouse gases. So both production and consumption along this whole chain have to switch and very rapidly change to non-harmful sources of energy. The second thing we have to do is stop destroying nature like our lives depend on it, because they truly do. We need these healthy ecosystems, again, for their beauty and inspiration, but also for our own survival. We need continued food production. We need land and oceans that are capable of taking up our carbon pollution. Right now, nature cleans up about half our carbon mess for free, but warmer oceans and more degraded land are less capable of continuing to do that. So it's really urgent to protect the nature that's remaining and to switch the relationship that people have with nature, reducing our extraction and making that more sustainable. I'm going to focus on carbon here, CO2, because carbon is highly correlated with other greenhouse gases because they are produced by similar processes. So when I talk about carbon, similar rules apply to methane and nitrous oxide, for example. And carbon is really critical because some of it lasts essentially forever. Up to a quarter of the carbon we emit today will be in the atmosphere for 10,000 years. So that's why it's so urgent that we completely stop this trend, this very steep curve that we see here of carbon emissions over the last century, most of which, the vast majority, is caused by burning fossil fuels. The remainder comes from agriculture and land use. What needs to happen is that number goes very rapidly to zero. And a depressing truth is that the longer we put this off, the harder the job is. So we really have a very urgent and tough job ahead of us, which is to go down this double black diamond ski slope of a very steep curve where we're shutting down fossil fuels and replacing them with clean energy. There are lots of studies about what it will take and what kind of pathways look like, but it's very clear that we're almost out of time. We've almost used up our whole carbon budget for 1.5 degrees. Current rates, if we don't make the necessary reductions, we will have used it up by 2030, and it will not be possible to limit warming below 1.5 degrees. So it's really now or never. So that means it's us or it's not going to happen. As I said, right now, we're not on track. Current policies, as I said, are headed for somewhere between 3 and 3.5 degrees of warming. Pledges and targets, so policies that may be put in place and are being adopted, are decreasing the rate of increase of emissions, but they're not even flattening emissions, actually. And what emissions need to do is dramatically decline. 1.5 requires we cut emissions about in half by 2030. And that is a heroic and enormous task. That's going to take all sectors. That's going to take contributions from all countries. Everyone has to drop whatever else you are doing and put your laser focus on making this happen, because this is going to be so necessary to sustain a good life on Earth. A little interlude from my favorite movie. This really doesn't leave much time for dilly-dallying. No, it doesn't. It would have been much easier if we had started sooner. It's a really huge job, but we simply have to do it. The alternative of suffering and extinction is just unacceptable. So what we have to do is actually get emissions to go all the way to zero. Carbon emissions actually have to go to zero because as long as there is any carbon in the atmosphere, humans are adding carbon to the atmosphere, we are driving further warming for hundreds to thousands of years, as I said. So this is in the Paris Agreement, and it's recognized in many countries' climate goals, if not yet in the policies that are necessary to achieve those goals, which is that sources and sinks have to be balanced. If you think of sources as basically fossil fuels and agriculture, and sinks are the land and the ocean, which is removing our carbon pollution. One thing that's important is going to the root of the problem and actually turning off the tap. We also need to increase sinks and allow nature to do what it does best in functioning in a healthy way. But we cannot rely on sinks. It is not going to be possible for even massive reforestation or afforestation programs to undo hundreds of years of fossil fuel pollution. So we simply have to stop burning fossil fuels. I want to look now, starting to wind up, at what that will mean on a more practical level. Some really interesting work by Diana Ivanova, just released a few weeks ago, showed how uneven carbon emissions are within the EU. So what this shows is, and we've seen that trend globally and within other countries, but I think this kind of detailed analysis is really helpful to focus our attention in this time where policies for green recovery and Green New Deal in Europe and the European farm to fork strategy and others are being discussed, because we really have to seize this opportunity to make these policies a reality. Right now, they found that 27% of emissions come from just the top 10% of emitters. So these were households. I don't have the number in front of me, but I think it was, I don't want to say the wrong thing, but basically the current mode of development is turn money into fossil fuels and emissions. And we have to rethink and undo this whole paradigm to stabilize the climate. Meanwhile, while 10% cause over a quarter of the problem, it takes the bottom 50% to add up to almost as much of the problem. So there's a huge inequality here. Our carbon budget, each and every one of us, wherever we live on Earth, whatever we're emitting right now, to make 1.5 degrees a reality, we all have to get down to 2.5 tons per person per year by 2030. That's very soon. That's like a couple election cycles away. So we have just a huge job in front of us. And of course, the higher emitting we are right now, the bigger job we need to take personal responsibility for to be in line with what's needed here. So you can see that this top 1% of emitters is 22 times over the limit. And most of that comes actually from travel. So you see the purple is air travel and pink is land travel. More than half of emissions there are from travel. So transport is a really urgent priority for focus. That's also the case in Sweden. We are on track to miss our climate law because we're not reducing emissions from transport fast enough. You can see out here that only about 5% of people in Europe at the moment are living within the carbon budget today. So the way I think we need to be thinking about this is how do we have a good life for everybody, meeting human needs and ensuring well-being while everybody lives within this carbon budget. And for some who are below having needs met, there needs to be more focus on improving quality of life. For others who are grossly over-consuming, we really need to be focusing on how to reduce those emissions and how we find a good quality of life at radically lower consumption levels. So you can, in the bottom and middle 40% here, so basically the lowest 90%, we're going to need to transform to a zero carbon society to make 1.5 degrees happen. So we have to change our energy and transport systems, industries, agriculture, and so on, because of course we need food, we need electricity, we need the services that are required for decency and dignity. But for the highest emitters, which used to include me and maybe many of us on this Zoom, we really need to eliminate our overconsumption and look at other ways of meeting needs that are not so out of line with what the carbon budget demands. Similarly with biodiversity, we have the solutions we need actually. We know what needs to be done. Stop expanding cropland. Switching to plant-based diets are some of the biggest and most urgent needs in places like Europe and North America, where we're really over-consuming meat products, and those are by far the biggest climate and other environmental impact. So Changes in production and consumption, both, again, similar to the fossil fuels. There's no one silver bullet. It's going to take a real shift in mindsets and then in the policies and practices to put those into place to actually make this happen, but it is possible. I'll just briefly mention a new study with colleagues led by Murray Scout at Luxus. What we found there from creating and analyzing a database of the Common Agricultural Policy is that almost half of that money, so about 26 billion out of 59 billion euros spent in 2015, this is the EU's single largest budget item, were misspent. They did not contribute to the goals. The CAP is aiming to reduce income equality by supporting a living wage for farmers and recognizing the important, essential role that they play in society. But what we found is that that 26 billion was going to areas that were already above the median farm income for the EU, where farm incomes were above the median EU income. So a lot of this money is paying already well-off farmers and not reducing income inequality, but rather increasing it. We also found that about 8 billion euros was supporting was used to support climate-friendly and biodiverse farming. So that is good news, but there was more that was going to the most harmful areas, the areas with the highest climate pollution and the least high nature value farmland. So right now we are using a lot of public resources to pay polluters, and that is going to have to change if we're going to actually stabilize the climate and the biosphere. My time is almost up here, so I'll just wrap up by saying I think embracing these three principles towards a mindset of regeneration instead of exploitation and overuse and overconsumption is really going to be necessary to inform our politics, our practices, our finances, the way that we go forward. And that is centering and respecting and protecting the needs of people and nature. Both need to be prioritized and protected, and we need to design economies and political systems that recognize that those are really not negotiable. Those are the core values that we need to protect. And do it in a way that is addressing the harm at the source rather than trying to clean up after a mess, while increasing resilience. And this is both ecosystem resilience, preserving function and diversity and options, and also community resilience, strengthening and empowering communities to be able to handle stresses that are ahead. So with that, I'll just reiterate, life on Earth is really in big trouble. It's up to us to fix it. We happen to be alive at this truly critical moment of life on Earth, and the next decade to 2030 is absolutely critical for really millennia to come. So the rest of our lives and the rest of human generations, many, many generations to come. So I hope that we rise to the challenge.